I'm Sonali Kelkar from City International School, and today we'll be learning the first chapter of chemistry as well as the first chapter of your textbook, that is chemical reactions and equations. In this chapter, we are going to cover the different topics which are chemical equations, balanced chemical equations, implication of balanced chemical equations, type of chemical reactions. You must have observed different changes in your environment and in your surrounding. And you can definitely differentiate between these changes as a physical change and chemical change. These changes you have already done in your previous classes. Let us discuss these changes once more time. In a physical changes, matter changes from one form to another form, but there is no chemical identity. Let us see the changes here. The first one is melting of ice. In the melting of ice, the ice changes into water, but the chemical formula or the composition of water doesn't change. Here we can see the chopping of wood. Here the structure of the wood changes, but as such no changes in the chemical composition. And as well as once you combine this wood, you will again get back the main component that you had in previously. Shredding of papers, here mixing gray and green marbles. So these all are the example of physical changes in which the composition of the material remains same or composition of substance remains same. These all are a reversible reaction. You can get back the same component again, the same subject or object again. Chemical changes. Here are a few examples of chemical changes. We know that chemical changes are most of the chemical changes are irreversible changes. Okay, in a chemical changes, of course, chemical reactions takes place. That is why these changes are irreversible changes. That means the initial substance that you had, you won't get back that initial substance. Let's take an example, burning of wood. Okay, the wood will burn and it will change into ashes, carbon dioxide, small particles. Here, ripening of banana or rotting of banana. You won't get the fresh banana once the banana got rotten. Mixing vinegar and baking soda. So whenever you mix vinegar with baking soda, this evolution of gas will take place. This is effervescence reaction. Then fireworks, right? These all are chemical changes. And now I want you to look at this picture, and I want all of you to differentiate between the different physical and the chemical changes. Uh, let's discuss photosynthesis. Now, which type of change is photosynthesis? Yes, it is a chemical change, because in photosynthesis, carbon dioxide and water is used to get glucose, and we cannot get carbon dioxide and water after we break down the glucose. Here is a glass with ice. Ice is getting melt, right? So this is a physical change. Digestion of food. Here the complex food material is digested in your stomach. It breaks down and you get nutrient from this food. So you won't get the food again. You won't get your apple again, isn't it? So this is also a chemical reaction. Baking, yes, it is also a chemical reaction. So once you bake your bread, you won't get that flour and sugar and everything back in its original form. Combustion, again, it is a chemical reaction. You are using LPG gas. Okay, once you have used that LPG gas, you are not getting back your LPG gas. So these you can now, I'm confident you can able to understand what is a chemical and physical changes. Okay, now different changes around us. that we have already discussed. There are physical changes and there are chemical changes. Now let us discuss the definition of chemical change. What do you mean by chemical changes, or what do you mean by chemical reaction? So whenever there are chemical changes, there is always a chemical reaction with that. Now what is chemical reaction? So a chemical reaction is a change in which one or more substance or reactant react to form a new substance with entirely different properties. It cannot be reversed by a physical method such as a magnetism, filtration, distillation, etc. Okay, now let's take few examples of chemical reaction. Types of chemical reactions. Digestion of food is a type of chemical reaction. We have discussed this before. Respiration is a type of chemical reaction. In respiration, there is an oxidation of glucose, C6H12O6. It is oxidized. Carbon dioxide, water, and ATP is released. Rusting of iron, iron has changed. Okay, iron reacts with water and it change. So definitely with that rusted iron, you won't get your iron back. So it is a permanent or irreversible reaction. Formation of curd, again it is a irreversible reaction. There is a complete change of milk. Burning of magnesium, ribbon in air. Regarding this, there is an activity in your book. So when you burn magnesium ribbon, before you burn, you have to wipe it with a sandpaper. You have to remove the extra magnesium oxide which is deposited on the upper layer of magnesium ribbon. You have to rub it and burn it. So when you burn, you will get magnesium oxide. Okay, it is again an irreversible reaction. Formation of hydrogen gas by the action of dilute sulfuric acid on zinc. This is again an activity taken from your book. In this particular reaction, on the zinc granules, you have to slowly drop dilute sulfuric acid. When you drop dilute sulfuric acid on zinc, there will be a reaction taking place where you are going to get zinc sulfate and evolution of gas, that is hydrogen. Now let's see the chemical reactions and how you are going to write the chemical reactions. Okay, so there is a particular procedure. There are certain rules that you have to follow while writing the chemical reaction. Okay, now let's start. I have taken over here a very simple reaction. Uh, Here is what hydrogen plus oxygen gives you water. So when you write chemical equation, okay, the whole chemical equation is divided into two parts. The first one is reactant. This is on your left hand side, and the next one, that is on your right hand side of an arrow, is product. The whole equation is divided into reactant and product, right? And when you write reactant, here also you have to follow a rule. That is, when you write one for first reactant, or let's take here you have written a hydrogen molecule, and there should be a plus sign between the two molecules, or if you are taking two compounds, so there should be a plus sign between the two reactants. Reactant can be element, they can be compounds, right? Then you have to put a arrow. Here this is an arrow which shows that reaction has taken place, and we are getting, after the reaction, we are getting water, that is H2O, which is the product. Okay, this is the final product that you will be getting after you react hydrogen and oxygen. I haven't balanced the equation. I will balance the equation later on when I will teach you how to balance the equation, right? Let's take another example. Magnesium plus oxygen gives you magnesium oxide. We did one experiment on this. We burnt magnesium ribbon. So magnesium ribbon is burnt in air. The oxygen is present in air. Definitely the oxygen is going to react with magnesium and you will get magnesium oxide. Okay, so here also I have written the reactants on left hand side. Magnesium and oxygen, these are the two different elements, and there should be a plus sign when you write two different elements or two different compounds and the product. This arrow sign is towards the product, so you are getting a product over here. There can be a reversible reaction where the reactant changes into product, as well as the product can also change into reactant. There are what are the reactants and the product in the given equation? This is a question for you all. I want you to solve the question in your copy. Though there are certain rules when you write chemical equations, please, these are very important rules that you have to understand first. See, over here I have written magnesium. Magnesium is an element, right? So magnesium is an element. We know that atomicity of magnesium is 1. So I have just written Mg. There is no need to write 1 over here because it's obvious that it is the atomicity is 1. In case of the first equation, H2, hydrogen is an element, but in a free state, hydrogen is not been found. Like in a single, as a single atom, it is always get combined with another hydrogen. So the atomicity of hydrogen is 2. That means 2 atoms of hydrogen has combined. This is a free state of hydrogen. This is a gaseous state. This is a free state. So that is why the atomicity of hydrogen is 2. There can be 1 or more, but not in other elements, not in case of hydrogen. Atomicity of oxygen is 2, so I have to write O2. This atomicity rule I am following with the elements. I am not following this rule with compounds, right? Now let's see the question which I have given you here. I have written H2SO4. Okay, so in this case you have to, this is a complete compound. Let's take this SO2, right? SO2 is radical, and we should know the valency of the radical as well as the valency of the compound, right? Because suppose you are writing FeSO4, so here Fe, the valency of iron is 3, so it has come over here, and valency of SO4 sulfate is 2, that has been written with iron. So this I think you have done in your previous classes, so I don't want to go in depth. You just have to make sure that you learn the valencies of different radicals. So let's, right. Before we start writing chemical equation, there are few information also that I have to share with you. That is writing symbol with a physical state. It is very important to write symbol with a physical state. For solid, I have to write S. For liquid, L. For gas, G. Make sure that you are writing this in small letters, not in capital letters. Aqueous solution is a solution where the solvent is water. Let's take, suppose you are mixing sodium in water, then it is called aqueous solution, right? So for aqueous solution, you have to write A and Q. There are further instructions also in which you have to write the atomic pressure, the temperature, or the heat release on the top of an arrow. Okay, let's discuss this reaction. Here, this is NaCl. NaCl, we all know it is a common salt. The chemical formula of a common salt. Aqueous is written over here. Aqueous means NaCl, salt is dissolved in water. So solvent over here is water. Plus silver nitrate. Silver nitrate is again aqueous solution. It is dissolved in water. NaCl and silver nitrate, sodium chloride and silver nitrate, both are reactants because they are on the left hand side of the equation. On the right hand side of the equation, what we are getting is silver chloride and sodium nitrate. Silver chloride is a salt and sodium nitrate is also a salt. Okay, regarding this equation, other information I am going to share when we will do the type of chemical reactions. Now, this is a very important part. How to determine the chemical reaction has taken place. There are different types of changes in chemical reaction. How can we say that chemical reaction has taken place exactly, right? So there are different type of it's not a formula. There are different type of changes that happens uh, in the reaction with the reactant, so that you can find out that this change is a chemical change. So let's discuss one by one all the point. uh, First is change in state. Hmm? So in this chemical reaction, hydrogen gas I have taken and oxygen gas I have taken. Hydrogen oxygen is mixed together and we are getting water. So there is a change, absolute change in the state. Reactants, both of the reactants were in gaseous state, and after they get reacted, the product is a aqueous state or is in a liquid state. It is in a liquid state. Now let us see the second change in the color. There can be the change in the color if there is a chemical reactions. Okay, citric acid with potassium permanganate. Potassium permanganate is a purple in color. When you add citric acid to potassium permanganate, the solution you will be getting, the product you will be getting after this will be the colorless, right? I want you to write the equation for this. That is why I haven't written equation here. Now, evolution of gas. Let's see, in this, zinc is mixed with aqueous, or you can say dilute. You can write aqueous, and if you are using a dilute sulfuric acid, you have to write Dl, and if you are using a concentrated sulfuric acid, you have to write CON. So here you have to take sulfuric acid, which is aqueous. That means sulfuric acid is mixed with some part of water. When the reaction takes place, we are getting the product ZnSO4, zinc sulfate, and hydrogen gases evolved in this reaction, right? And I think you all know how to check the evolution of hydrogen gas. You have to bring a burning splinter, and if there is a pop-up sound, you can make out that the gas released is a hydrogen gas. Then change in the temperature is another change in the reaction, which will clear that the reaction took place was a chemical reactions. Calcium oxide, which is a quick lime. When you add water to calcium oxide, you will get calcium hydroxide. This is slaked lime, and heat is evolved during this reaction. If you do this reaction in a test tube, you will find that test tube got heated up. And this is for you all. I want you to solve these questions. You have to write the physical state and balance the given equations, right? Now let's do few more things. Yeah, there is one more step, formation of a precipitate. How to determine the chemical reaction has taken place? So there is a formation. There can be a formation of precipitate. I have taken this example from your textbook. This is again an activity in your textbook. It's a very beautiful reaction I want teachers to do with you in the class. Here you have to take lead nitrate, take an aqueous solution of lead nitrate and potassium iodide. When mixed together, you will be getting a yellow precipitate of lead iodide. A beautiful yellow precipitate, you can see in the picture, lead iodide, and a clear liquid, that is potassium nitrate. Oh, this is here we have completed our portion of this particular slide. I want you to write these equations. You can consider it as a homework. So please write the balanced chemical equation for the following. Thank you so much, and practice your chapter.